All right, so we are moving on to rational expressions. Okay, so when you see the term rational, what you need to think is fraction. Okay, rational expressions are fractions where we're going to include some variables sometimes. Okay, and so you'll see different presentations of different types of questions that you may encounter with rational expressions. So we're going to go through those different types. But we'll start off with some basic ones. Okay, so the first type of problem that you may see, our first example here, we'll say to evaluate, or at least it should say evaluate. And it'll look like this, right? So x minus 1, there's my numerator, I promised a fraction, over 4x plus 5, okay? And they're going to give me some additional information. They want me to evaluate the rational expression for when x is equal to 5. Okay, so when x is 5, I want to know what does this fraction equal. All right, and we know how to do this, right? This is the substituting a number in, right? You're plugging numbers in. That's what I'm going to do here. So I'm going to say x minus 1 over 4x plus 5, but we're no longer calling that x, right? We just said that x is 5. So I'm going to put 5 in for x. Okay, I'm going to simplify this. 5 minus 1 is 4. On the bottom, we have 4 times 5, which is 20, plus 5. 20 plus 5, yeah, I'm just going to write 25, right? I'll be a little lazy. 25. So it turns out that the expression here, this rational expression, is equal to 4 over 25 when x is 5. Okay, well, let's do another example. All right, that was easy enough. Let's see if they're all easy. Let's play that game, right? So 7y squared minus 2 over 11y. And I want to evaluate that rational expression for when y is equal to negative 10. Okay, so in other words, what does this thing equal when y is negative 10? All right, so let's plug it in. 7y squared minus 2 over 11 times y. And we just said that we're going to say that y is negative 10. All right, so let's do our math. All right, our math magic here. Negative 10 squared, negative 10 times negative 10 is 100. So that's going to be 7 times 100 minus 2 over 11 times negative 10. Of course, it's just negative 110. Okay, let's keep going here. Order of operations says I should do that next. 7 times 100 is 700. Look at that big number here. Minus 2 over negative 110. I don't like writing the negative in the bottom, so I'm just going to kick it to the outside here. It means the same thing. All right. Write that a little neater. Okay, and then 700 minus 2, 698, or 110. I can reduce that, right? So let me reduce it. Let's say I divide those both by 2. So 698 divided by 2 is 394. I'm sorry, 349. I cheated a little bit, used my calculator. I know. Shouldn't do that. And that's 55 on the denominator there, and I think that's about as simplified as I can go with that. All right, so there we go. That's our second example. So that was fun, right? Let's do a third one. And then we'll move on to another problem type. So 15x minus 2 over x squared minus 3x minus 4. And again, I want to evaluate that expression for when x is equal to negative 7. Okay, so I think we know the drill by this point. This is 15 times something minus 2 over something squared minus 3 times that something minus 4. All right, x is negative 7, so I'm going to go through and plug in negative 7 where x is supposed to be located. All right, so 15 times a negative 7 is a negative 105. Okay, minus 2 over negative 7 squared. Negative 7 times negative 7 is a positive 49. Negative 3 times negative 7 is a positive 21 minus 4. All right, what does that come out to be? Negative 107 over 49 plus 21 is 70 minus 4. It's going to be 66. All right. Okay, and then can I reduce that, right? 107 over 66. Yeah, I don't think so, right? So that'll just be my answer. All right, so that is what we're talking about when I say evaluate. Okay, evaluate an expression. Okay. Let's talk about restrictions. Okay, restrictions. And so what I'm talking about when I say restrictions are numbers for the variable that I'm not allowed to plug in. Okay, so in other words, let's give you an example to look at here. 2 over 7x plus 1. Okay, remember certain things that you're not allowed to do in math. You shouldn't have a negative under a square root, usually, right? You'll see that that's a lie later, but in general, you're not supposed to have a negative under a square root, and you're also not supposed to divide by 0, and we're going to stick to that rule, right? We cannot divide by 0. So in other words, this denominator right here cannot equal 0. It's possible, though, that depending on the x value that you plug in, the bottom could equal 0. Right, and that's what we want to avoid. So any x value that you plug it in for x right here can cause the denominator, right, this whole thing to equal 0. That x value would be a restriction. So the question becomes, how do you find it? Well, you just take the denominator, 7x plus 1, and you set it equal to 0. If you solve that equation, then you know the x value that you need to make it equal 0. Okay, well, let's solve it. So subtract 1 from both sides. So we have 7x equals 0 minus 1 is a negative 1. Divide both sides by 7, and I get that x is equal to negative 1/7. Okay, well, x is not equal to negative 1/7. We know that x cannot equal negative 1/7. All right, if that happens, then we break a rule, right? We break the rule of dividing by 0. All right? I don't know if you believe me, so let me show you, right? I mean, what else am I going to do? So we have 2 over 7x plus 1, and we just said that negative 1/7 is our restricted value, right? It's a restriction. We cannot plug it in. Okay, well, watch. I'm going to do it anyway. 7 times negative 1/7. Okay, well, 7 times negative 1/7 is negative 7 over 7, which is just negative 1. Okay, that was a waste of time writing that. That's going to be 2 over negative 1 plus 1. Well, negative 1 plus 1 is 0. Uh-oh. 2 over 0. Oh, no. Right? And then another hurricane comes. This is my hurricane. Okay, never mind. I got excited. I had too much sugar tonight. Guys, I apologize. All right, example 5. So here is a rational expression. And the question is, are there any restrictions, right? Find the restrictions. Are there any? And find them. And you can have more than one, right? It is possible. That's a period. There we go. All right, and so again, the focus here is to take the denominator, right, the bottom part, set it equal to 0, and that's how you're going to identify the numbers that you do not want to plug in, right? So 4x squared minus 4x equals 0. And by now, we should know how to solve that, right? That's a quadratic equation. I can factor out a common factor. Hopefully, we see that the common factor is 4x. Okay. What's left behind if I factor out a 4x? Right? If I divide these by 4x, what am I left with? 4 cancels. X squared cancels, leaving me with a single x. And those cancel, leaving me with a 1, right? So I'm going to clear all that out, but I don't know. Maybe that helps. Maybe not. Okay, and so we're left with x minus 1. Okay, and then the zero product property will apply here, right? Something times something is equal to 0. So I know that I can set the individual components, right, equal to 0, the individual factors equal to 0, and solve these, right? So if I divide both sides by 4 on this one, I get x equals 0. If I add 1 to both sides on this one, I get x equals 1. So this one has two restrictions. X cannot equal 0 and x cannot equal 1. Okay, not too bad. Notice, by the way, this is a common question that I get. We completely ignored the numerator, right? We didn't touch the numerator. That's because to answer this question about restrictions, the numerator is completely irrelevant. Doesn't matter at all. All right, let's do another one. Example 6. Here we have x minus 3 over x squared plus 2x minus 3. Okay, and again, I just said that the denominator is what I care about. The numerator, completely irrelevant. So I'm looking for the x values that would cause the denominator, x squared plus 2x minus 3, to equal 0. So I can solve this, right? I can solve by factoring. All right, so I'm not going to bore you with a whole factoring lesson right here. You can always go back and watch that video. But I do know that the first two numbers have to multiply together to be x squared, so x and x. I know that I have to have a positive and a negative. That's the only way I get a negative right here. And to get 3, I have to either have a 1 and a 3, or a 3 and a 1, right? And since this middle one is positive, I need the bigger number to be positive. All right, look at that. I factored it. You can always check it by going 3x minus 1x, so positive 2x, right? When you put those together, it's positive 2x. Okay, again, I don't need to review all of that. Y'all are smart enough at this point. Okay, so anyway, x plus 3 times x minus 1 equals 0. Zero product property says that x plus 3 equals 0 and x minus 1 equals 0. Right, two equations that are both relatively simple to solve. X plus 3 equals 0 gives me x equals negative 3. X minus 1 equals 0 gives me x equals a positive 1. So I have two restrictions. X cannot equal negative 3 or 1. If I plug either of those in, I get something over the bottom equals 0, right? So we don't want that to happen. Okay. Let's do one more of these restriction type questions, and then we'll go on to the last type of question. And this is my favorite one when it comes to restrictions. 5x plus 10 over x squared plus 6. All right, well, set the denominator equal to 0 and solve it. Maybe you recognize this, maybe not. This is a sum of squares, sort of, kind of. If you remember, that one is not factorable. More importantly, though, if you ever come across something like this, always just subtract the 6 from both sides. Get x squared by itself, so you can try to use the square root property, where you use the square root of both sides. But we talked about another rule earlier, right? X would equal positive and negative the square root of negative 6. You can ignore that. If you did the square root of both sides, what would you be doing here? Square root of a negative, right? We can't have that, at least not yet. So if you come across square root of a negative, that means there's no real solution to that equation, to this particular equation. There's no real solution. And if there's no real solution to that equation, well, then it turns out there are no restrictions. That's why it's my favorite one here. I can't even solve the equation because there are no restrictions. All right, moving on. Example 8, we'll talk about the last type of problem that we'll see in this section. And these are the ones that say simplify. Okay, simplify. And so when you think about simplifying a rational expression, think about simplifying a fraction. Okay, the same idea. So let me not a real example. Let me write something. Let's say we have, I don't know, 16 over 12. Okay, 16 over 12. I can reduce that, right? How would I reduce it? Well, I know that the top and the bottom are both divisible by 4. So if I divide the top by 4, I would get 4. If I divide the bottom by 4, I'd get 3. Okay, what am I really doing? if I think about 16 as its prime factors, in other words, the numbers that all multiply together, the prime numbers that when they multiply together equal 16, which is 2 times 2 times 2 times 2. You can try that in your calculator if you don't believe me. And if I do the same thing with 12, 2 times 2 times 3, you'll notice that certain things will divide out, right? 2 divided by 2 is 1, so it kind of cancels out. It really just becomes 1 times all this stuff. So basically non-existent. Same thing happens here. I'm left with 2 2's on top, which happen to multiply together to equal 4, and a 3 on the bottom, which happens to multiply together to be 3. So, or not multiply, it's equal to 3. So the same idea will be true. What I'm going to try to do is break up the rational expression into the numerator and denominator and see if I can cancel things out. Okay, that's going to be my goal. So, example 8. Y squared plus 6y plus 8 over y squared plus 5y plus 6. That looks ugly. Okay, what I do not want anybody to do, the big mistake, right? Don't go crossing that out and crossing that out and then crossing these out, right? Don't do that. Goodness gracious, don't do that. All right, the reason being is that you can only cancel things out, like in our previous example, right? If everything is multiplied, right? Once you start putting plus and minus in there, you're breaking up the terms, okay? You don't want to do that, okay? You can't do that. So what should you do? Oh yeah, factor, right? So again, I'm not going to bore you with the whole factoring shenanigans here, but let's see. What multiplies together to give me 8 but adds up to 6? That's going to be a 4 and a 2. The bottom, what multiplies together to be 6 but adds together to be 5? It's going to be a 3 and a 2. Okay, now everything's written out as a product. Yes, I see a plus, but notice it's within the parentheses, right? So there's multiplication happening. All right, so maybe you notice y plus 2 and y plus 2 can cancel each other out. I'm left with a simplified version of this expression, y plus 4 over y plus 3. And it turns out that these are equivalent. Okay, if you actually try to graph such a thing, I don't recommend it just yet, but if you try to graph such a thing, they'll be the same graph with one minor exception, which you'll learn about in college algebra. Okay, but again, think about that as the reduced version of the fraction. Let's do another. This one's just ugly for no reason other than just to be ugly. So let's talk about that one. All right, so anything that's this ugly, of course, you should look to see if you can simplify it at all before you try to simplify it. I worded that terribly. You should look for a greatest common factor to make the problem look nicer before you try to simplify it the rest of the way. All right, so hopefully, if you look at the numerator, you recognize that they all have an x in common, so I can factor out an x. That leaves me with x squared in the first term. That leaves me with 3xy on the second term. And that leaves me with 2y squared on the third term. On the bottom, I can factor out an x as well. That leaves me with x plus y. And before I go even further, I might notice that, hey, since this is multiplication here, and here everything's multiplied, I can actually cancel out those x's. So already I've simplified this problem. X squared plus 3xy plus 2y squared over x plus y. That's where I'm going to pick up and finish this problem. Okay, I'm going to ignore all the stuff that came before it. I need to factor the top. Okay, maybe I should walk through this one considering that it looks a little different. So I'm going to say, off to the side here, I'm going to do it in a different color so we don't get confused. All right, I'm going to do the factor by grouping thing again. I'm going to sort of kind of ignore the y squared for now and just focus on the 2. Okay, if you ignore the y's, that's what I'm going to do. I'm going to ignore the y's. If you ignore the y's, x squared plus 3x plus 2 will factor to be x plus 2 and x plus 1, right? Because x times x would be the x squared, 2x plus 1x is 3x, and 2 times 1 is 2. Okay, but notice we have y's, right? We have y's. Okay, maybe if you just put the y's right here, so 1y, maybe that'll work out. Okay, why would I do that? Because think about it, 2y times y would give me 2y squared. So it accomplishes that goal. I know those two have to multiply together to be 2y squared. So these two give me the x squared. These two give me the 2y squared. Let's see if it multiplies out in between like we need it to. Okay, so 2y times x is 2xy. You could say 2yx as well, but usually put them in alphabetical order. X times y is 1xy. If I add those together, I get 3xy. Yay, it actually factored, okay? So, cool. X plus 2y, x plus y over x plus y. Notice, by the way, I kind of cheated. I really didn't, but I kind of thought about this, right? If this denominator is x plus y, and the whole goal of this section is to simplify things, it'd be really convenient if this factored to include an x plus y in it. Okay, just little tips to watch for. All right, anyway, so that cancels with that. I know this one wasn't in parentheses, but if it were, you would see it a little bit easier. It cancels out. It's not in parentheses because it's not multiplied times anything, right? All right, anyway, so that leaves me with x plus 2y. That's all that's left. Okay, so that ugly example simplifies all the way down to x plus 2y. All right, we got two more examples. None as complicated as this one. They're a little tricky in their own right, but they're not that complicated. Example number 10. I hope I haven't skipped any. 4x minus 8 over 2 minus x. Okay, factor out a common factor. Okay, so if I look at the top, 4 can come out x minus 2. And then I have 2 minus x on the bottom. I'm not going to write that yet on purpose, but I realize that 2 minus x and x minus 2 are not the same thing, right? They look a lot alike, but they're not. Difference between having $1,000 and having $1,000 taken away from you, right? Big difference. So what I'm going to do is, it's a little trick, something to watch for. It would be convenient if this negative x right here turned into a positive x, right? So then it would match up with this one. And this positive 2 right here would turn into a negative 2, so we can watch that one. I want to flip the signs. I can always flip the signs by factoring out a negative 1. If I factor out a negative 1, the positive 2 becomes a negative 2, and the negative x becomes a positive x. Now, again, these don't look quite alike, but they're the same, right? Positive x, negative 2. I can write it again to make it a little bit more obvious. And then you can see they clearly cancel out to leave me with 4 over negative 1, which is just a negative 4. Negative 4. Okay, so anytime you see something like this, which is very close to this, and you want to cancel it out, but you realize all your signs are backwards, just factor out a negative 1. It'll force the signs to match up so you can cancel it out. All right, finally, example 11. Negative 3x cubed y cubed over 12x to the 5th y squared. All right, I saved this one for last because it looks different than the other ones, okay? It's actually not difficult, though. Recognize that everything is multiplied already, okay? So I don't have to worry about factoring anything. Everything is already multiplied. What I can do, though, is isolate 3 different scenarios, right? I have negative 3 over 12. I have x cubed over x to the 5th, and I have y cubed over y squared. I can handle these one at a time. negative 3 over 12. Let me actually write it out. Negative 3 over 12 times x cubed over x to the 5th times y cubed over y squared, right? Just so you can see it a little bit better. You don't have to write it out like that, but it's just so you can see it. Okay, negative 3 over 12 is negative 1/4. X cubed over x to the 5th. Do you remember our exponent rules? Right? You subtract the exponents if they're the same base, which in this case, of course, they're the same base. Subtract the exponents. The bigger one's on the bottom, so what's left over is going to be on the bottom. So 5 minus 3 is 2, so I'm left with the understood 1 in the front, still going to be there. 1 over x squared, right? Again, 5 minus 3 is 2. Times, okay, y to the 3rd, y squared. 3 minus 2 is going to be 1, so that's going to leave me with y to the 1st power over 1, right? Again, the understood 1 that was there. And then I multiply this out. So negative 1 times y is going to be negative y. 4 times x squared times 1 is going to be 4x squared. And there we go. All right, so that would be our introduction to rational expressions.